Now what we're going to do is we're going to use the power reducing identities to reduce some different looks. And we got two different looks in our example 3. Rewrite each expression in terms with no power greater than 1. And we're going to accomplish this using our power reducing identities. So we have to look at some flexibility in how we can rewrite things. This first one says cosine to the 4th of x. So cosine x to the 4th. One of the ways you can rewrite this is say it's the cosine squared of x raised to the 2nd. Now there's other ways of writing it. This is the way that I prefer to write it. I know I have a cosine squared reducing formula. The reducing formula that I have for that says I can rewrite that as 1 plus the cosine of 2 theta divided by 2. Now we were supposed to take that value and square it. So this is what we're going to have to do. We're going to have to square this expression. So it's going to be 1 plus cosine of 2 tangent, or 2 theta squared. And I suppose since I want to keep the variables consistent, it would have been wise to keep this an x. So I'm going to put an x in there. So I got to square this binomial. So to square that binomial, I get 1 plus 2 cosine of 2x, then plus cosine squared of 2x. That's all over 4. Now we were asked to write this so that we didn't have any powers greater than 1. I still have a cosine squared in there. So again, we're going to utilize our power reducing identity. So it's 1 plus 2 cosine of 2x. Then plus, we're going to replace the cosine squared of 2x as 1 plus the cosine of. Now this is 2x, and it always says take double your angle. So the first time I did it, the angle was just x. But this time the angle is 2x. We're always supposed to double that angle, so it'll be 4x. So I've made that replacement for our cosine squared of 2x, and it's 1 plus cosine of 4x all over 2. And then we've got the fraction bar of our original fraction, which was a 4. So now it's a matter of getting rid of that denominator on the bottom. My first impression is I want to get rid of that 4 over 1, so I'm going to take this top equation, or top part of the expression, and multiply it by the reciprocal 1/4. If I multiply top and bottom by 1/4, it gets rid of our complex fraction, and now I can distribute through my entire term. So that's 1/4 plus, we take 1/4 of 2, so that should be 2 cosine of 2x. Only I wanted the 2 on the bottom because it's a 4. So it's cosine of 2x all over 2. Then plus, if I take 1/4 times this, it'll end up giving us 1/8 of 1 plus cosine of 4x. And you could put it all over 8 if you wanted. I'm not really sure why I changed in midstream on that. What I would do at this point, and what they show you, is that they factored out a 1/8. So if you factor out a 1/8, what's left out of all this? Well, this one's the easy one, but if you factor out a 1/8 out of a 1/4, that means you're multiplying it by 8, so that should be a 2. Then, plus, if you factor out a 1/8 out of 2, that means you're multiplying by 8, that should be 4 cosine of 2x. And you can see if I redistribute that, that is 2/8 or 1/4. If I redistribute that, that is 4/8 or half. So those stay just like we want them. Then we factored out the 1/8, so it's going to be plus 1 times the cosine of 1 plus cosine of 4x. So that's still just going to be 1 plus cosine of 4x. And that's all we're going to have inside those parentheses. Then we can grab our like terms. So it's going to be 1/8 times 2 plus 1 is 3 plus 4 cosine of 2x plus the cosine of 4x. And that's the finalized version of it. That's reducing it all the way down so we don't have any powers higher than 1 in our expression. I am going to come back and I'm going to show you the expression for sine cubed of x. I'm going to make it a separate video. So I'm going to stop this video and I'm going to create a new one just for that, and I'll put that in the YouTube selections as well.